Okay, so today what we're going to do is we're going to look through and walk through every piece of this. So as I do them, I'm going to be putting out other ideas that you need to write in your notes if you don't understand what I'm talking about. But we'll go through every one of these. We've got a nice long time to do this. So the first one, question 1. The height in meters of a ball thrown vertically t seconds after the throw is given by, then they give you an equation, yeah? And they want to know how high is the ball after 2 seconds. This is simple substitution. If they give you an equation and then they give you a value, that always simply means plug in that value in place of the letter.
Sorry, I was just doing it to keep these.
Yes, you can write on these. They're yours to keep. Okay? After we enter the grades in a minute. All right, so let's just look at what that means for this particular question. All right, so we have our function, or our equation, h equals 20t minus 5t squared. And we want to do that after 2 seconds. And it tells you that the time, t seconds, the time is t. So t equals 2. So that means just everywhere there's a t, you're going to put a 2. And remember I told you that if you ever replace a letter with a number, you always put it in a what? Bracket to hold the operation true. So h equals 20 times 2 minus 5 times 2 quantity squared. So all I did was, everywhere there was a t, I plugged in the 2. Right? And again, I'm using 2 because they told me after 2 seconds. So what if they said after 5 seconds? I'd put a 5 in. Right. Okay? So h equals 20 times 2 is 40. Order of operations here says I have to do the exponent first, right? So 2 squared makes what? 4. And negative 5 times positive 4 is? Negative 20. Excellent. And 40 minus 20 is? 20. So the final height is 20. And make sure that you put the units 20 meters. Okay? Some of them are simple. Let it happen. Okay? All right. So if you're given an equation and some value, you know that all they really want you to do is substitute the value in and work it out. Be careful there. Watch out for and make sure you use brackets because it can change the exponents, etc. if you don't. Okay? All right. Are we ready? All right, to go to the next one, I have to lose all my writing. So everybody got that? All right. Remember, it'll also be on the video if you want to go back and look at any of these. Okay? Let's look at the second one. Given the diagram below shows a rectangle, all right, the diagram shows, given that AB is equal to CD, find the value of X. Okay? So let's just talk about what they're saying. It says AB is equal to CD, right? Well, here's line AB. Here's line CD. Do you agree? Mm-hmm. And what it says is those two things are equal. So all I need to do is replace the name of the line with the value. And then solve the equation. So, what is the value given for line AB? 3x minus 5. And that has to equal the value given for the line CD. What's that value? Now we have an equation that we can solve. Do you see? It tells you that these two things have to be equal. So you just take that value and set it equal to that value. Okay, now it's a linear equation because we don't see any exponents. So I need to get all my x terms on one side. So I have 3 x's and 1 x. I'll move the 1 x. And since it's positive, even though you don't see a plus there, you know it's positive. We'll move it by subtracting it from where?
Both sides.
Both sides. So 3 x's minus 1 x gives you what? 2 x's. Minus 5 equals 1. And you can do this in less steps than I do, but I want to make sure that you see every possible thing. Now that my x's are on one side, I want my numbers where? On the other side. So what number do I need to move? The minus 5, right? Because 2 is not a number, it's a coefficient, right? So I'll move minus 5 by doing what? Adding 5 to both sides, yeah? So they subtract away there. That gives me 2x equals what? 6. Is my x completely by itself then? Yeah, no. It's connected to that 2 by what operation? Multiply. And what? I'm sorry?
How did we get the 2 as the first one?
3x's minus 1x, just left with 2x's. Right?
And 1x comes from that side.
Right. If you have just plain old x, remember you can always put a 1 in front if that makes it easier for you. Okay? Now, the opposite of multiply by 2 is what? Divide by what? 2. So we'll divide both sides by 2. Over here, that leaves me just plain old x. And what's 6 divided by 2? 3. And there's your solution.
See, I didn't do that, but I still got
Yes, I
3. Somehow.
did not do that, but I still got 18.
Yeah.
Because you can just guess, still it's very low numbers.
Yeah, they were very, but remember you probably got credit for guessing the right answer, but remember that gives you a US. And so that means that it can count as your U, but only once. So be careful.
The way you work it out was invalid, but it's not the way.
If it's also valid, then you got credit for it.
Because I think I did it, but then I just kind of went with one answer that ended up being.
Yeah. Okay? All right. Here we go. Ready? Let's look at the next one. So if it says two things are equal, then just set them equal to each other.
Oh, this one was really hard.
I was so sad. This is one of the ones we went through together, but it's all right. It's okay. There's an error in this student's working. Correct the error and find the value of x. Well, you know what? If it says correct the error and find the value of x, just do it yourself. Ignore that. Don't look at their work and then try to figure out what's wrong with it. Do the work yourself and then compare your working to their working, because it's going to drive you crazy sitting there looking at their stuff. Right? You're going to have to do it yourself anyway. So we have 3. So we have 3 to the x plus 1 equals 81 to the x minus 5. So this is an exponential equation. We've talked about that, yeah? And so for an exponential equation, these are easy to solve as long as the bases of the exponent are what? The same. Well, I can't turn a 3 into anything. 3 is a prime number all by itself. So I need to see, can I turn an 81 into some power of 3?
Yes.
Yeah. Think about it. 3 times 3 is 9. 9 times 3 is 27. Times another 3 is 81, right? So that's 1, 2, 3, 4 3s. 4 factors of 3. Do you agree? Mm-hmm. Right? You can always find it by just multiplying them out if you don't know what it is. So 3 to the x plus 1 equals 3 to the what power? 4th power. But we already have the x minus 5 up there, right? So it's 3 to the 4th power raised to the x minus 5 power. And this is where the next student made the mistake. If you have a power raised to a power, he added them. Is that what you do?
No, you
Well, power multiplied by a power, it means multiply them.
Yeah.
Right? So it's 3 to the x plus 1 equals 3 to the 4 times x and 4 times 5. Negative 5. So 4 times x is 4x. 4 times negative 5 is negative 20. And that's where the mistake was made in the original work. It should have been multiply right there, not add. Because you're raising a power to a power. Remember, so if you had 3 to the 2nd raised to the 3rd, that's the same as 3 to the 6th. You just multiply the exponents. And if you will use brackets, that would tell you that, because what's the bracket always mean? Multiply, right? Okay? Now, since I have the same base now, what do I do to solve it? Throw out the base, because I don't need it, and set the exponents equal to each other. Remember, we did these in class?
Wait, why do you throw out the base?
Because it's the same base, so that means the exponents are all we need to look. We're looking for what exponent, right? And so I'm looking for the exponent, so I only use the stuff from the exponents. But again, you can't do that up here because they weren't the same base. They have to be the same base first.
So you just work it out now?
Yeah, now you just solve it. So again, that's 1x there. Let's get our x's on one side. So we'll subtract 1x from both sides. Gives us 3x minus 20. Now we need to let me write it up here so it's a little clearer. 1 equals 3x minus 20. We need to get our numbers on one side. Well, our x is over here on the right, so my numbers need to go to the what? Left. Good. So I'll move the negative 20 by adding 20. Remember, you just do the opposite, right? 20 and 21, 1 and 20 make 21 equals 3x. The x is still not by itself yet. The 3 is connected to the x with what operation? So side by side means multiply. So the opposite of multiply by 3 is what? Divide by 3. Yeah. 7. And x, so that gives you x equals 7. Yes. Okay.
I'm so annoyed.
Monday. Oh, their error is right. Yeah. The error is right there. They added the exponents instead of multiplying them. Okay.
Why do we put the plus 20 underneath the negative 20? They're just going to cancel out.
Well, because I'm just showing the working. You don't have to if you don't. If you can do it without showing all the working, that's fine.
If we don't
I
write
always.
That on that side and just write it on this side.
It makes it more simple.
It's okay.
Is there an easier way of doing this?
Okay? All right. Okay? All right. Now that was a... Let me look at the key. Just to... Yeah, that was a merit question. If you got 7, that's a merit question.
Even if you didn't...
If you show no algebra, then it's not going to work.
Oh,
You've
no,
got to
but
show the algebra.
Like, you know that's... Like, if you just highlighted it and just worked it...
If you saw that and then you worked it out from that point for yourself and fixed it, yeah, it'd be fine.
Okay.
Yeah. Most people aren't good at looking at someone else's work and finding the mistake and then going from there. Most people are better at just starting from scratch and then go back and compare. So it's totally up to you. If you could find the other student's mistake, then correct it and finish out the problem, that would give you full credit as well. All right? Okay? All right. Yes?
Wait, here we didn't actually correct the student's error. So do you actually need to say what their error is, or do you just need
Well, they were assuming you'd correct the student's error and then work it out. It's fine. As long as you pointed out the error, then it's fine. We multiplied the 4 times the x plus 5, where they added the 4 to the x plus 5. And that's what threw their answer off.
You know, you have to show working. But if you gave an answer and you gave a statement about why you got an answer,
If you don't show algebra, I can't give you credit. And you're going to see there were, I think, 2 of you that are going to see that on your paper. All right, let's go to the next one, guys. Okay. Following table shows the first 5 counting numbers squared. Now, this is going to require that you have a little bit of knowledge about the pattern for squared numbers. All right? If you remember that the first squared number is simply that thing squared, right? The second squared number is the first number plus 1 squared.
Sorry, can you stop this? The first number is...
Okay.
Just simply... That
First number is just take the number and square it. So like the first number is 1, and so you square 1 to get a 1, right? If you add 1 to 1, you get what? 2. And then if you square that addition, you get what? 4. So that means if you did the third one, and then it just keeps on in that pattern. Add 1 again gives you 3, and 3 squared is 9. Add 1 to 3, you get 4, and 4 squared is 16. So there's your pattern, right? The first one is always just the number squared, and the second one is n plus 1 quantity squared, the whole thing squared. And they'll build up from there, all of them. Okay? Now, What does it says? It says, show that the difference between these two consecutive numbers is always an odd number. Many of you try to do the common difference thing, right? Where you took like 4 minus 1 gives you a 3, 9 minus 4 gives you a 5, and then you got all odd numbers. Some of you did, many of you did that. That is fine, except this is an algebra test. Is subtraction algebra?
No.
So you can't get credit for that, even though you were showing that the common difference was always an odd number. But watch what happens. Now remember, anytime you're trying to say the difference between things, change, it's always the second one minus the first one. So it's going to be n plus 1, quantity squared, minus the n squared. Change is always the new minus the old one. So some of you subtracted it in the wrong order.
But what's the new one in this?
Well, we got the first one, right? So if you have a first one and a second one, which one did you get first? The first one. So that's the old one. And the one you got second is the
second minus the first.
new one. Okay? No, you're not going to get a number because you got n's in there, right? Now, in order to work that out, we have to get rid of the brackets. Because I can't subtract an n squared from a bracket, can I? So what does n plus 1 squared mean to do? It means n plus 1 times what? N plus 1. So you must expand the brackets. So n times n is n squared. N times 1 is positive 1n. Positive 1 times n is another positive 1n. And positive 1 times positive 1 is positive 1. And from that, we're still what? Subtracting n squared. Which is nice. Why?
I have a question.
N squared will subtract away. Yes?
If there's a difference, right, what if there was a third? Does that matter?
It
Wait, why is there just a one?
Because
doesn't
if
matter
it's the
because
same
it's
as
always going to be n squared. It's the
But
difference
say
between
it
two
was-
of them.
Say up there was a third, would it be n plus 3 or n plus 2?
No, n plus 1 squared is always the next number is always n plus 1 squared.
What's the cell?
Okay?
Why is there just one on the cell?
I beg your pardon?
Why is there
Expanding brackets is not a new topic here. Anytime you have a bracket raised to the second power, that means you have to take the entire thing times what? Itself, right? And you just take the first one times the first one times the last one. Then you've used that one up. B times A is another AB. B times B is B squared. So you just multiply it out. Okay?
I read the first part.
That is a critical skill, and if you know how to do that, you can get a couple of U's out of this thing. Okay? Now, we also have this, right? What's n plus n going to give us? No. 2n
Why is it take
plus 1. Okay?
Oh no, because it was new ones.
Oh, it's got to be minus.
Okay. Okay. So they're wanting to see that you can square a bracket. Right? They're wanting to see that you can combine like terms. And then they want to see that you can use logic. Those are the three things they're looking for. If you memorize the pattern here for squared numbers, they could care less if you have to derive that pattern. It makes no difference.
One and the first one. And the second.
So, let's move forward. Come on, guys. Yeah. What if it was n plus 1 to the third power?
Then you do it 3 times.
Then that do bracket, bracket, bracket. Don't worry about why would it be. I'm just making that up.
You
Okay?
would get
All right, just so you can see the difference. No way. Couldn't be. All right, here we go. Come on, guys. Okay. This one made me sad a little Because again, it's just substitution.
You gave me
And
the
one of you did an amazing job of knowing something. Was it you? So somebody just went, somebody went, hey, an x plus 2 times an x plus 2 is a square. So if I take the square root of the number it's equal to, then x plus 2 has to equal the square root, which is really good, but it ain't algebra. Did you? I was so impressed.
That's right.
Good job. But I couldn't give you credit for it. I couldn't give you credit for it. Okay, so here's the deal. Look, the volume of the box. They gave you a formula right here. What is the volume? No. Just tell me what number, what value.
147 centimeters.
So 147. And we don't need the units in right when we're doing the math, okay? What is the length? I don't care. You can call any one of them you want to the length, except for this one, because that's up, so that's a height. So if you call that one length, this one width, this one is the height. So what's the length?
X plus 2.
X plus 2. And they're connected together with what operation?
Times.
Yep. And I told you do not put anything in there without using a bracket. If you do, it's going to be a mess if you forget the brackets. All right. What's the width? Another x plus 2. What's the height?
3.
3.
Does the 3 just sit there? Is it not like a...
It means to multiply all that stuff together. And remember, we've talked about this. If you're multiplying, if two things are the same, in other words, you have a bracket times a bracket. Come on, guys. Shh. All right, so if you have a bracket times a bracket, then you should do the brackets first. And then we'll deal with the 3. So what's x times x make? What's x times positive 2 make? Positive 2x, yeah. What's positive 2 times another x make? Positive 2x. What's positive 2 times positive 2? Positive 4. We can combine those two middle pieces. You always can when you square a bracket like that, right? So we get x squared plus how many x's? 4 x's plus 4. Now, did we have another multiplier though? Yes. So we still have to multiply all that junk by what? 3. Now, there is a shortcut for that if you understand it, and you can use it, and it's perfectly fine. But if you don't, then I'm not going to mess with it. I don't want to mess with it. Okay. So that gives you 3x squared plus 12x's plus what? 12. Okay? And it still equals what? There you go.
Do we put the...
Wait, it's actually really simple. I actually know what I'm doing.
All right? So all I did was multiply the two brackets and take that answer times my 3. Shh. Guys. All right. Now. Okay? Hold on just 1 minute. Now, that just gives me the equation. I still have to solve it. Right? Okay. Yeah, it's a trinomial. So we have to set it equal to what? 0. So that means I need to move that positive 147 to the other side. So it's 147 equals 3x squared plus 12x plus 12. To move the positive 147, I'm going to subtract it from both sides. Remember, it's a quadratic, x squared, so that means you have to set it equal to 0, then factorize it to solve it, right?
Does that say plus 12x?
Plus 12x plus 12. Mm-hmm. Yeah. So 3x squared plus 12x won't change. But what is 12 minus 147 going to make?
Minus 135.
135? Now, we have it set equal to 0. What's the second step in solving a quadratic equation? Well, factor. And what's the first thing you look for when you're factoring? GCF. Is there anything common to all of these? You betcha. They'll all divide by 3. And you know that because pretty much, I told you, remember, that when you're factorizing on this particular test, every one of them had a common factor. So 0 equals 3. So now we're taking the darn 3 out again. All right? So x squared plus 4x minus, what's 135 divided by 3, someone?
Negative 45.
45.
How do you just know how to do that with no calculator?
Exactly.
I cannot.
Yeah.
Well,
Did you do it like right then, or did you do it like a while ago?
you want me to show you how I knew there was a 3 common? Shh, hold on a minute. How did I know?
Because it went into 12.
Because I multiplied it by 3 a while ago.
Oh, right. Because he multiplied it by 3.
We multiplied it by 3. We put that 3 in there, so we know it's there.
But how do you know that 135 divided by 3 is 45? You just like...
You do long division.
I don't have time to guess. That one go well. So you go
3 won't go into 1. 3 goes into 13 how many times?
4.
Which is 12. 3 goes into 15 what? 5 times. You all went to primary school.
No, we didn't learn this in primary.
You put the 4 up there. There's one left over, so you put it
In
in
primary, I learned how to count in my 9 times.
4 times 3 is 12. Subtract the 12 from 13, you get a 1. Bring down the 5. Yeah, it was already in your numbers. Yeah.
Okay.
Yeah, y'all do it differently. Y'all stick the 1 there. That's fine. If it makes sense to you, I don't care. It's all right if that's the way you do it.
Moving on.
Okay? All right, let's finish this up. Now, I still have to factorize the stuff inside. 0 equals 3 times. I'm going to get 2 brackets, right? My A is 1. So 1 times negative 45. It gives me an AC of negative 45. I'm trying to find the 2 factors of that that'll combine to make positive 12. Yes? Okay. Remember factorizing?
Oh, I know.
All right.
Wait,
So 1 goes into it 45 times, but that won't combine to make 12. 2 won't go into it. 3 goes into it 15 times. Well, they add to make 18. Is that what I want? No. But 15, they subtract to make 12. Is that what I want?
Wait, 12. Don't you want to make 4? 9 and 5.
Oh, I'm sorry. Trying to make 4. Thank you, guys. I did that on purpose. I get it. Okay, here we go. Come on. So 3 and 15 won't work because we're trying to get 4. I forgot. All right. 5 goes into it how many times? They won't add to make 4, but they will subtract to make 4, right? And we want our 4 to be positive. Therefore, our 9 must be positive because you keep the sign of the bigger, right? And does a negative times a positive still make the negative that I started with?
Yeah.
Yes. So we're good there. So then we're going to replace the b term, that middle term, the 4x, with those 2 new numbers. So it's 1x squared. I got to have some more room. Okay. So it's 1x squared minus 5x's plus 9x's. Shh, guys. Minus 45. Break it in half. What's common to the first 2? X. We divide out an x, you're going to get x minus what? 5. Bring down that plus. What's common to the second 2? 9. Divide them by 9, you get x minus what? Knew it was going to be x minus 5 because the brackets have to what?
Be the same.
Be the same. So you get x minus 5 and x plus 9. Now that I have it factored, I set each one of those factors equal to what? 0. So the first factor is what? 3. But can 3 equal 0? So we toss it out if it doesn't make sense. Then we get the second factor is x minus 5. That equals 0.
Can you just get rid of it?
It doesn't work. We're rejecting it. Remember, you're always allowed to reject stuff that doesn't work. So here,
Don't you have to give an answer?
we add 5 to both sides to solve this one. Gives us x equals what number? 5. We subtract 9 from both of these to gives us x equals what? Negative 9. I'm also going to reject that one. Can anybody tell me why? Do you know how long a box is? The box is negative 9 inches long. That can't happen. We can't have a negative. So the only one that's possible is the 5. So that means x has to be 5. But remember...
I put x equals 5. Yes.
Oh.
I didn't get it in mark.
Okay. Well, show me...
X equals 4. I guessed to the next. I got 5.
Well, show me why. Now, I would, if I were you, I would rework this one until I could do it in my sleep.
I shall be doing
Just as a...
Oh, yeah.
And 3 can't equal 0, can it? So you have to toss it out. If it doesn't make sense. I'm going to the moon today. What are you going to do with that piece of information?
Ignore it and say
Throw it out because it's stupid, right? It doesn't make sense. It can't happen, right? You see stuff like, you do this all the time. Things that don't make sense get tossed out. You do it all the time, yeah?
Wait, so you can just divide it by 3 and then not do anything?
I set it equal to 0, just like all the other factors. But does 3 equal 0? Right? 3 doesn't equal 0, so you can't have it. And as a matter of fact, anytime you have a common factor that's a number, toss it out. Because it can never, no number can ever equal 0 other than what? 0. And you can't have a common factor of 0 because that means you started with 0. So, okay? All right. We threw out that 9. Remember, why did we throw out the 9? Because length can never be what? Negative. Okay? So you have to write that. It has to be written. Okay? Finding the number x equals 5 is just a merit. Saying the reason why you can only have 5 and not the negative 9 is the excellence part of that question. Okay? So if you throw out an answer, tell why. And that's always the excellence part. Because length can never be a negative number. Yes. Okay? All right, here we go. Let's look at the next one. Start beginning of question 2. We have an equation. It says find an expression for t in terms of v.
That means like switch it, right?
So what that literally means is solve for t. And remember, we talked a lot about what that means. It means that we want that t to be what? Completely by itself, yeah. And we do that by doing the opposite. Yes, this is those subject change ones, but you don't have to worry about that. It doesn't need some crazy name. All I want to do is get the t by itself. Yeah? Is the t by itself right now? No. So I'm going to rewrite it so you can see it a little bigger. V equals 6t squared plus 4. Now remember, here's the term that has the t in it. So what do you think I want to move first?
The 4.
The 4.
JK.
Right, because it doesn't have anything to do with the t. So let's move it first. And we move add 4 by doing what?
Take away.
Yeah. Now, can I subtract a 4 from a v?
No, you just need it.
So I just get v minus what? 4. Over here, they subtract away. And what does that leave me on that side?
6.
Okay. Is my t by itself? No. There's a number with it that I need to get rid of. How do I get rid? And 6 times t. So what's the opposite of multiply by 6? Divide both sides by 6. Now on this side, 6's will divide away because it's 6 times, right? They're opposites. That's going to leave me my t squared. And on this side, can I divide a v by a 6? Nope. So it just stays v minus 4 all over 6. Don't try to do the math on one side. It ain't going to happen. Okay?
Is that it?
Is my t by itself? No, it's squared. How do we unsquare something? The square root of what? Not just one side, but what? Both sides. The square root of t squared is t. Now, here's where some of you went kind of south on this, and I gave you credit for it, even though I shouldn't have. V minus 4 over 6, the square root of all of it. Here's what you did, some of you. You got there, but you did this. And that says take the square root of only the top. Are we taking the square root of only the top? Nope. We're taking the square root of the whole thing. So make sure that your radical encloses that entire expression. Okay? You know who you are. Okay. You're too funny. And now, technically, when you take the square root, you get a positive and a what? Negative value. For some reason, they don't count off if you don't write that. But really, you should be writing plus and minus in front of anything that you take a square root of. Because there's a positive and a negative value. The reason why they don't bother so much is because you have a variable in it, but if you put the plus and minus in it. But again, it's not on the mark scheme, so I didn't worry about it.
Will it ever take points off?
And that's just a U question anyway. No.
Okay.
No. Okay? So technically it's t equals plus and minus this thing. But that's okay if you just write it like that. Okay? But make sure you do extend the radical all the way around the edge. Okay? Now, again, this is not... The first time you ever see something, you're not going to go, oh, well, miracle, I understand it perfectly. You never have to worry about it again, right? I can do it for the rest of my life. Yeah? Yeah, if that were true, there would be no professional sports. Or driving. Or anything else. Or there would be no accidents on the motorway. Because you know how to do it perfectly, right? So do it. Everybody's going to do it perfectly because they've done it once. Baloney. Okay? All right, here we go. Baloney's not as good as Duda? No. All right, here we go. Let's look at the next one. Given that all interiors of a triangle add to 180.
Wait, so what's the answer?
Is it the answer?
That's the answer.
Wait, what was it?
The t is the t by itself? Yeah, the t is by itself, so that's the answer. Okay. Come on, guys.
Wait, Mr. Sal, do we have to put this? Yeah?
All right, here we go. Given that all interior angles of a triangle add to 180, find the value of x in this triangle. Oh, this is another one that made me sad. Because it says they do what?
Add to 180.
To make what?
Oh, so it would have been 180.
So it's just this one plus this one plus this one equals 180. Simple linear equation.
Oh, I didn't put the equals 180 on the end.
It made it.
Is that the answer?
No, we still got to solve it.
Is this a cheat question?
Yes.
Oh.
So x plus 2x plus 3x makes what? One of them plus two of them plus three of them makes what? 6 of them. 10 plus 20 makes positive 30 equals 180. Now we need to get the x by itself by first what? Subtract the 30 from both sides, which gives us 6x equals 150. How is the 6 connected to the x? The opposite of multiply by 6 is divide by 6. Gives you x equals what? Pardon?
25. Well, yeah.
And because it's angles, 25 what? Degrees.
I am so
No,
annoyed. That
don't-
is the easiest question
don't
you
do
guys
it.
had. And I didn't even. I was so dumb that I just think it was
Okay. So there. So all we had to do was first factorize. Second,
It's basically my dumbness.
divide away
Gave me the right answer.
common factors.
Subtracted.
Right? So that's all this is to it. Now the factorizing does require a little work, but that's all. That's where the work is in this one. And that's a merit question, guys.
What does that word say? Divide.
Divide away common factors. CF, common factor. Okay?
Yeah, suddenly I have
It's
all
good?
this knowledge.
Okay. Now again, it doesn't do you any good to see something once if you're not going to practice it. So this might jog your memory. What I'm really working at here is to show you the method so that you can go back and practice it. You have the method, you have the answer, you have the
What's this
process.
called? These-
Yes, pardon? Oh, it's just simplifying fractions. Yes.
With that answer, how do we know that that's like the end?
Because is there anything else that would common do them?
There's still a 2 outside the brackets.
What now?
There's still like a 2 outside the brackets.
It's fine. Is there a 2 in the bottom?
No, but
So there's
you
nothing
don't
left
have
to do.
Like,
Oh, multiplied out?
yeah.
Yeah, nah, there's no point.
Okay, so don't.
So don't bother. Now, if you did 2x minus 10 over x plus 4, I don't think that would be counted wrong, but in reality, you don't need to, so what's the point? Yeah. It's not going to help you.
Because you're not trying to like solve.
You can only divide away factors, so you should leave it factored.
Yeah.
Make sense? Okay? All right. Okay, here we go. Next one. Oh, here's another one that's just straight substitution. All right? Doesn't matter that it's Pythagoras, right? Just all it says is, here's the formula, plug in what you know. Now, you do have to bring some prior knowledge of geometry, a little bit. What do you know about the long slanted side of a triangle?
It is
Longest.
8.
It's the
It's the
hypotenuse.
hypotenuse.
So in other words,
H.
that's H. The other two, it makes no difference. Okay? But for that one, you have to put that one in the right place. So what am I going to put in place of H? 10. And remember, they're all squared. So then I'll just use this one and this one. So x squared, oops, sorry, not times, plus x plus 2 squared. Now, I want to point out something that they're going to do to you a lot. Look at this. Haven't we seen x plus 2 squared before?
Is it 3?
Yeah, in the table when it was in. Oh, no.
Not in the table, but in another problem. They're going to do that a lot. If they're not going to, if you know how to multiply out a bracket once, then they're going to give you the same bracket over and over again because it doesn't matter if you do it again. Right? Okay. What's 100 squared make?
You mean 10 squared?
squared.
It's 100.
I'm sorry, 10 squared. There we go. Oh, well, duh. 10 times 10 is 100.
100.
X times x is
X squared.
plus. X plus 2 squared, quantity squared, means x plus 2 times another what?
X plus 2.
So I would recommend taking it off to the side. Unless you have it memorized from the last one, you can just flip over from the other problem. It's x times x is x squared. X times 2 is positive 2x. 2 times x is another positive 2x. 2 times 2 is positive 4. What can I do with those two pieces in the middle? Yep. So it's x squared plus 4x plus 4. Yes, I'm going fast, but this is not the lesson. The lesson is how to do it. You go back and study these. This is not to study. This is to show you what you need to study, right? Mm-hmm. Okay, so yes, I'm going fast. But that's well. Now we'll combine our like terms because we see that both of these have x in them, right? X squareds. So 100 equals how many x squareds?
4.
No. Remember, it's one of them plus one of them makes two of them. Plus 4x plus 4. Which is what kind of equation? Well, quadratic, because the highest exponent is a 2. So this first step is to set it equal to 0. Does it equal 0 now?
No.
Nope. We need to subtract the 100 from both sides. Oh, be careful, not 104. 2x squared plus 4x. 4 minus 100 is negative 96. Do you notice that all those numbers are even? Which means we have a common factor of what? 2. So 0 equals 2 times x squared plus 2x minus 48.
Why do you put it in brackets?
Because I have a multiplier in front.
Oh, you're right.
Yeah?
Oh,
So I took out a factor, so now it has to be in brackets to show that that means multiply it times all of them.
Yes.
Now we'll factorize this thing. So x squared plus 2x minus 48. Okay? AC method. So 1 times negative 48 is negative 48. Looking for the two factors of negative 48 that'll make 2. Well, 1 and 48 won't do it. 2 and 24 won't do it. Okay? 3 and 12, no, it's 4 and 12, right? 4 and 12 won't do it. 5 doesn't go into it. 6 goes into it what? 8 times. And won't 6 and 8 make
Yes.
2? If the 8's positive and the 6 is negative? Yeah? Bring down that x squared. Remember, that never changes. What do both of those middle things need to have in them? X's. And bring down your negative 48. Break it in half. And find the common factor. What's common to x squared and negative 6x?
X.
X, excellent. X squared divided by x is x. Negative 6x, divide out the x, you get what? Yeah, be careful.
No, 6.
Negative 6, right? Because the x divides away, but there's no number to divide by. Bring down your plus. What's common to 8 and negative 48?
8.
You know you've got to get it to make an x, right? So it has to be the 8. Okay? Think about your brackets have to match. That'll kind of give you a think about what to divide by. 8x divided by the 8, you get what? Negative 48 divided by positive 8 is?
Negative 6.
There you go. So x minus 6 times what? X plus 8. Okay? Now, so we have it all factored. So it's 0 equals 2 times x minus 6 times x plus 8. Now we're just going to take each one of those factors and set them equal to what? 0. What is the first factor? Does that work?
No.
Yeah. Toss it out. Can't happen. 2 can't ever equal 0. What's the next factor? X minus 6 equals 0. What's the next factor? X plus 8 equals 0. Add 6 to both sides here. Gives us x equals what?
6.
Subtract 8 from both sides here. Gives us x equal what?
That's wrong.
Negative 8, which we hate. Okay? All right? So, therefore, x equals what? 6. But notice what does the question say? Find the x. Find the what? Sides of the triangle. Well, we already know this one's 10. We know that this one down here, x equals what? 6. So this one is 6 plus 2 or what?
8.
You must have them all. And you must also tell me why you tossed out your negative 8.
Because it's negative and...
We can't have a negative.
Can't have a negative
Would you say
length.
that's hot?
Length. Whatever. Yeah. Your measurement cannot be negative. However you want to put it. Okay?
And what kind of question is this?
All right. This one would be an excellence question. You would get merit for finding the 6, but you would get excellence for finding the sides. So just one more thing, adding 2 and you get excellence.
How did you know that
The H, it's always the long slanted side. Yeah. Hopefully you learned that that's why we do the right angle stuff. Yeah. Okay. Yeah. So memorize that one because if anytime you use a triangle, that long slanted side is always the hypotenuse.
And then to the other sides, we not matter.
Nope. Because you're adding them, so it doesn't make any difference. I usually use the smallest one the first, and then the bigger one second, so I can.
I know how I did it, but I just didn't.
But they're the same steps over and over again. So look at it. So think about it. Okay. Here we go. What's next? Can I just tell you that I love these problems, and then y'all can go ahead and hate me? This is my favorite thing to do is algebra like this.
We missed that question, and we don't have
We don't have that question.
I don't have that question.
Oh.
I don't have that question.
I don't have that.
Oh, I don't
All
care.
right, because remember that, yeah, they took some out. Don't worry about it.
There we go.
We got stuff. We got other issues that we need to worry about. This one, guys, come on. All right. Oh, look at that. How disappointed am I? All right. I fell over. I was so disappointed. Here we go. Come on, guys.
I got this.
So just treat it like an equation. So we have 4x plus 7 is greater than 15. I've got to get the x by itself. So what do I need to move first?
Take away 7.
Take away the 7 from both sides. Gives me 4x is greater than what? 8. Divide both sides by what?
4.
Am I dividing by a negative 4?
No.
So nothing is going to happen to that symbol. And there's your
So if you
answer.
divide by a negative, it's the symbol.
Flips over.
When I did this question, this is it.
What?
Like, just your answer is 1.
Then you got it wrong.
8 divided by 4 is 2, not 1.
When I did this question, it's definitely not how I did it. I just thought in my head, 4 times 2 is 8 plus 7 is 15, so there has to be more than 2. It's 17.
Yeah, which is fine, except that it's not algebra.
But then you got that.
Was that only gonna change question?
Because I gave it to you because you had the right answer because,
And then, because I didn't write.
right. That's one of those, I can use my discretion to give you one if you get the right answer without using algebra, using guess and check, but only one. Okay? Why do you divide by?
The 4.
Well, how is the 4 connected to the x? How is that 4 connected to the x? What operation? 4x literally means 4 times x. And what's the opposite of multiply by 4? So you do the opposite. You're just simply doing the opposite operation.
Wouldn't it be 1 if you 4 by 4 is 1?
Well, yeah, but it's 1x. So 1x doesn't do you any good. So 1x is just the plain as x. If you write 1x, you're perfectly happy. It's fine.
I wrote x equals 1, so.
Yeah, no. X doesn't equal 1. It's 1 on that side, but it's 1x. And 8 divided by 4, gosh, that's messy. 8 divided by 4 is 2. All right. Okay. Come on. Let's get to Stephen. And anyway, that makes no sense. Okay, so here we go. We have our equation, right? T equals 0.5 n squared minus 7n plus 31.5. Now, every time he did it is the n, the number of times he did it. So n equals how many times he did it, right? And and it tells you on the what try? So what number am I going to put in place of n? So t equals 0.5 times 4 quantity squared minus 7 times 4 plus 31. Simple substitution problem. 4 squared is 16. 0.5 is the same as 1/2. So what's half of 16? 8. Negative 7 times 4 is negative 28. Plus 31.5. Yeah? Okay. So 8 minus 28 is negative 20 plus 31.5. Which gives you t equals 11.5 potatoes? Seconds. Okay. Simple substitution problem. If they give you an equation and they give you a value, that means you substitute it in and do the math. Right? Okay? So be careful. Now, the next one requires some knowledge. We've talked about it briefly, but we didn't beat it up as much as we did factorizing. It's paid off big. All right. Sum of 3 consecutive integers. Remember that the first one you always call what? No, these are just consecutive numbers. Integers. N or X, whatever. You want N? Okay, I'm fine with N. First one is N. What's the second one?
N plus 1.
What's the third one?
N plus 2.
Oh, x is fine.
They're always one bigger, right? Consecutive numbers are always one bigger than the next one, yeah? What does sum mean to do that you're doing?
Addition.
Adding them together. So N, that's this one, plus this one, so that's N plus 1, plus this one, so that's plus N plus 2. Yes, you have to carry the N to all of them because it's not plus 1 and plus 2, it's N plus 1 and N plus 2, right? So make sure you have all those N's. Now let's combine those like terms. What's 1N plus another N plus another N going to make?
3.
Plus, what's 1 plus 2 make?
3.
Okay? If you factorize that, that shows that you are always multiplying this number by what? 3. Okay? And you're taking a number here and multiplying that. We are supposed to show that it's always divisible by 3. Well, we know it's divisible by 3 because it has a common factor of 3. So it's divisible by 3 because it has a common factor of 3.
Do I write that in the sentence?
Yeah.
Done.
That's done.
Are you serious?
And that's a merit.
No, freaking. Why is that whole thing so much easier to find?
I feel like they just made the question.
Why did you put it into a bracket just now?
Because I was just showing that that they both would divide by 3.
But is it?
You don't have to. You can leave it right. You can leave it like that, and say they both would divide by 3. Therefore, right?
Wait, so what are you going to write in the
Yeah, what do you have to write?
Can you just like give it a little?
They have a common factor of 3.
Oh well.
And common factor means that they both divide by what? Or you could write, or they both divide by 3. Right? Because you're saying they divide by 3. So both numbers divide by 3, therefore they both divide by 3. Okay? All right. Come on, we got one more.
Oh well.
Here. Now this one uses something that we have not talked about. That's where one or more equations equal the same thing. Okay? And look what it says. The diagram shows a regular hexagon. The interior angles are all equal to 120, right? So this thing equals what?
120.
This thing equals what?
120.
This thing equals what?
120.
So therefore, I have one or more equations that have all equal what? 120. Well, that's the definition of a simultaneous equation. Okay? No, the answer is not 120. That's just how we know they're simultaneous equations. So, okay, what that tells you is that, guys, listen, we don't have much time. Whatever x is in one of them, it's the same thing in all of them. Whatever y is in one of them, it's the same thing for all of them. So I'm going to show you how to do it by substitution. There's also a method called elimination. If you know it, it's faster. But substitution it just means plugging numbers in, right? Okay? So first, solve 1 for x or y. It doesn't matter because x and y are the same in all of them, right? Okay? Not set it equal to 0. Solve one of them for x or y. And it doesn't matter. Now, I would probably use either, if I call these A, B, and C, I would probably use A and C because what do you notice about A? The y is all by itself. Do you notice that?
Yeah.
And do you notice in C that the x is all by itself? I would probably use those. But would it matter? No. So let's just solve A, and we're going to solve it for the y.
It says solve for both.
Well, pardon me?
It says solve for x and y.
That says or.
No, but the question says and.
Yeah.
But these are the directions on how to do it, though. Okay? All right, we got to do this first. So simply subtract 2x from both sides, and you get y equals 10 minus 2x.
Wait.
All I did was solve for y.
Y equals 10 minus 2x. Awesome.
Get the y completely by itself. Is the y by itself?
Yes.
Then it's solve for y.
Oh, so that's why.
Yeah. Substitute that value
Substitute.
into one of the other equations.
Yes.
Why?
I should have because.
Okay?
No,
No,
why
doesn't
does it say
equal to
2x plus y equals 10? Because I thought the equation is 2x plus y plus 10.
No, it says equal. Oh, does it say plus? I'm sorry. Plus 10. I'm sorry. I'm so sorry. So sorry. Equals 120. I'm very sorry. That was my that was my mistake.
I was just wondering.
It's tiny and I'm old. So we subtract this writing is so tiny and I can barely see it.
You can like erase it off.
Okay.
And, like,
So y equals negative 2x. 120 minus 10 is plus 110. I'm sorry. Because remember, we know what they equal. They all equal what?
120.
120. I even wrote it down there and I didn't use it. Okay? Now, so what does y equal? No.
Minus 2
There you go.
Wait, why is it minus? Because you put it on the other side.
Because I subtracted positive 2x, took it away from both sides.
Oh, right.
Okay. Now,
Oh, exactly.
I can put this value. So what does y equal again, guys? Negative 2x plus 10. I can put that in place of y in one of the equations.
That doesn't look like it says
Okay.
plus 10.
Plus 110.
Where's the negative 2x on?
So that's what y equals.
It's plus 110. Just,
Doesn't need
all right. Okay. Now, so any equation, which one you want to use? Let's put it right here. So we have 4y, what is that, minus x?
Do you want to
4y minus x
Oh,
minus
I could look on the paper. That
4y
would make my
minus
life
x minus
easier.
50.
4y minus x minus 50 equals 120. Okay? So in place of y, right there in place of that y, what am I going to put?
Minus y.
Negative 2x.
Equation.
Yeah.
Do we have to put on brackets?
Yeah.
No, I'm just joking.
Okay? So it's going to be, because 120, we subtracted the 10. That's where you got the 110.
I wasn't meaning to distract you. That's so good.
That's all right.
Yes.
Don't forget I'm a teacher. I hear everything you'll say. It's not a silly question.
Everything's a good question.
No, that's all right. It's no big deal. All right. Now, 4 times what? Negative 2x plus 110 minus x minus 50 equals 120. So now what's happened is I don't have two variables anymore. I just have one, an x. And I can solve that. I can't solve something with an x and a y in it. So let's start. 4 times negative 2x is what? 4 times positive 110 is positive 440. Minus x minus 50 still equals what? 120. I have two variable terms, so let's combine them. So what's that make?
Negative minus.
Good. I have two numbers on the same side, so let's combine them. What's 440 minus 50 going to make?
390.
Positive 390. Still equals what? 120. I need to get the x by itself by subtracting the 390. Gives me negative 9x equals negative 270. Then I'm going to divide both sides by what? Negative 9. Yeah, make sure you need the negative and the 9 to divide away, right? Over here, the negative divides away. 270 divided by 9 is 30.
Do you not plus it?
No, you just divide because it's negative 9 times. There you go. Yeah, be careful about that. So, what's x equal then? Well, if x equals 30, then x equals 30 when? All the time. Okay? So now all we need to do is substitute that value
Back into the y.
to find the other.
Wow.
So it's really it's a complicated, there's a lot to it, but it's not hard. Now, so we'll take this 30 and put it anywhere in place of what? Be careful, x. It's x equal 30. Anywhere in place of x. Does it matter which one?
No, but we should just use the first one.
Okay, we want to use the first one? Fine with me. I don't care. Why don't I care?
Because it's
Because if x is 30 in one of them, then what?
the same in the other.
It's the same in all of them. So simultaneous equations are not difficult. So you want to use a, right? So 2x plus y plus 10 equals 120. In place of x, I'm going to put 30. Yeah, make it, use your brackets. 2 times 30 is? Plus y plus 10 equals 120. Combine 60 and 10, you get what? Plus y equals 120. Then what? Subtract 70 from both sides and get y equals what? So x equals what? 30. And y equals what? And there's your answer. And again, Do I expect that you're going to memorize this process from seeing it one time? No. So go back over it and practice it. I can tell you that every MCAT I've seen has simultaneous equations on it. Every one of them. This is not difficult mathematics. It just means you need to do it. Now, I can also tell you that there's another process for solving simultaneous equations, the elimination method. If you know it, great. If you don't, substitution is easier to learn. It's not as fast, but it's usually easier for most people to learn. Okay? So if you look again, if you want to look at elimination, I'm happy to make you a video or talk about it on Teams or whatever, right? Okay? But for now, you know you can use substitution. Okie doke. There you go. So practice these, guys.